Hey, 42 here. As science and technology continue to demystify the world around us, we humans have a bad habit of assuming we already know it all. But the truth is, whilst we're discovering new things about the nature of our universe all the time, we've barely scratched the surface when it comes to knowing everything there is to know. There are plenty of secrets out there just waiting to be revealed, and there's a good chance we're going to find some of them in the most unexpected of places. Take our very own solar system, for example. It's easy to think that in 2021, thanks to millennia of stargazing and the recent introduction of some pretty nifty telescopes, we know exactly what's going on out there and where. But the solar system is a big place, and once we travel past its 8 planets and their 200 odd moons, our understanding of our own cosmic backyard is surprisingly sketchy. So much so that some scientists believe the furthest reaches of the solar system hide a truly giant secret, an undiscovered 9th planet. And we aren't talking about some diminutive planet wannabe like Pluto, or Ceres. If proponents of the Planet 9 theory are to be believed, our solar system's currently unidentified 9th member is actually kind of a monster, as much as 10 times the mass of Earth and 4 times its radius. This postulated planet is portrayed as a kind of stealthy puppet master, hinting at its own existence by subtly adjusting the orbits of millions of distant asteroids and dwarf planets with tendrils of gravity. Pretty intriguing, right? But how could such a huge planet remain hidden in our very own solar system even today, when modern technology is helping us unravel the inner workings of galaxies halfway across the known universe? To put some context around that question, Planet 9 is thought to be hanging out around 600 astronomical units from the solar system's center. An astronomical unit being the average distance between the Earth and Sun. In the context of our solar system, 600 AU is a very, very long way indeed. By comparison, Neptune's orbit puts it at a mere 30 AU from the Sun. But in the context of the universe, where distances are usually measured in light years, 600 AU is nothing. The most distant object from Earth ever detected is a galaxy known as GNZ11, and it can be found a cool 32 billion light years from where you're sitting right now. When we train our telescopes on GNZ11, we're seeing the universe as it was just 400 million years after the Big Bang. Admittedly, galaxies are a tad bigger and brighter than planets, but even the most distant exoplanet so far detected, an exoplanet being any planet located outside of our own solar system, are much, much further away than Planet 9. First observed in 2006, Sweeps 4 and Sweeps 11 were found orbiting a star in the constellation Sagittarius. They're approximately 27,700 light years away from Earth. Which means the most distant planets known to humans are around 3 million times further away from Earth than Planet 9 is purported to be. Think of it as the astronomical equivalent of a cryptozoologist discovering a tribe of yetis high up amongst the cloudy peaks of the Himalayas without ever realizing one had been living in his garden the whole time. And that slightly odd analogy leads me back to the same question. Is it really possible that a giant planet could be lurking in our solar system without us realizing? Before we get into all of that, why do people believe Planet 9 even exists in the first place? The search for our solar system's 9th member began over 100 years ago with a man named Percival Lowell, who became interested in astronomy after reading a book about Mars. Most people who get into stargazing buy themselves a book or two and invest in some kind of simple telescope. But Lowell happens to be a member of that particular cross-section of society known as rich people. So he kicked off his new hobby by building himself an observatory on the top of a mountain in Arizona. Lowell was a very smart guy, but it's fair to say he was probably more famous for his crazy ideas than his good ones. On the crazier side, he believed there was life on Mars and that he'd found evidence to prove it. Of course, the idea there may be life on Mars isn't particularly controversial, even today. But Lowell wasn't talking about life of the microscopic variety, more of the little green men kind. Another of Lowell's bold but possibly mental ideas was his belief in the existence of what he called Planet X, which sounds like it should be the birthplace of a Marvel supervillain, but was actually just a name he gave to a hypothetical ninth planet he believed was hiding in our solar system. For all his harebrained schemes, Lowell appeared to have a pretty good reason to suspect another planet might be lurking somewhere out there. He determined that the orbits of the outermost planets in the solar system, Uranus and Neptune, were slightly different to what mathematics predicted based on our existing planetary model. Almost as if they were being tugged off course by some kind of distant, massive object. Planet X. Lowell began searching for this elusive celestial creature in 1906, devoting the entirety of his energy to the endeavor. But the years went by without success. It's said Lowell became so obsessed with his quest that his inability to find Planet X eventually killed him. Though I should point out his coroner saw things a little differently, recording Lowell's cause of death in 1916 as a stroke. Despite Lowell's demise, his passion and a large chunk of his cash ensured the search for Planet X continued after his death. And in 1930, the breakthrough was finally made when Clyde Tombaugh discovered a new planet using the telescope at Lowell's very own observatory in Arizona. Our solar system's newest inductee was duly named Pluto, partly in tribute to Percival Lowell, its first two letters matching his initials. You see, you're only mental until you're right. As you can probably imagine, the folks at the Lowell Observatory were pretty bloody pleased with themselves at this development, and much slapping of backs and haying of fives ensued. But those good vibes didn't last long. Because it turned out, the reason it had taken decades to find Pluto was that it was very, very faint and very slow moving across the sky, suggesting it was a lot further out than the other planets and probably pretty small. These suspicions were confirmed in 1978 when Pluto's moon, Charon, was discovered, allowing astronomers to definitively determine the planet's mass. As it happened, poor old Pluto was a tiddler, just 1/6 the mass of our own moon. Such a diminutive, distant planet would have been about as capable of knocking planetary heavyweights Uranus and Neptune out of their predicted orbits as I would be of knocking Anthony Joshua onto the canvas to become heavyweight champion of the world. I.e., not very. It was clear Pluto was not the Planet X Percival Lowell was looking for. But wait a minute, if Pluto wasn't causing Neptune and Uranus's orbital oddities, that meant something else was, right? Actually, wrong. Because it turns out the whole dodgy orbits of Neptune and Uranus theory has been one giant cosmic red herring all along. A fact that was proven in 1989 when Voyager 2 visited Neptune and discovered we'd misjudged its mass. When astronomers plugged the correct values into those complicated astronomical equations they're all so fond of, they discovered the orbits of both Uranus and Neptune had been exactly where they were supposed to be the whole time. And that was officially the end of Planet X. The theorized ninth planet in our solar system had never been there in the first place. If I'd made this video a decade ago, it would probably have ended right here. and I would have been up a suit and down a mustache, obviously. But over the last 10 years, astronomers have begun whispering about Planet 9 once more. Because whilst Lowell's belief in a hidden ninth planet turned out to have been founded on a massive mistake, weirdly enough, it seems the conclusion this false trail led him to may just have been correct after all. Perhaps the best known Planet 9 theory today was put forward by astronomers Konstantin Batygin and Michael Brown in 2016. And their hypothesis isn't all that different to Lowell's from 100 years before. Batygin and Brown had also discovered orbital anomalies that were difficult to explain based on our current understanding of the solar system. Though in this case the orbits were of extreme trans-Neptunian objects, ETNOs, rather than planets. ETNOs are a group of solar system satellites orbiting the Sun far out beyond Neptune in the most distant parts of a region called the Kuiper Belt. We think there are literally billions of these asteroids out there, though to date we've only found and catalogued around 2,000 of them. The ones we've found so far seem to share some pretty unusual properties. We're talking orbits that are perpendicular to those of the planets, and almost everything else in the solar system, orbits that travel the opposite way around the Sun to almost everything else in the solar system, and perhaps most significantly of all, orbits that seem to be clustered together in a very specific, very non-random way. So, what's causing all this weirdness? You guessed it! Planet 9 is back! Considering how badly things went with the first astronomical expedition to find Planet 9, it's easy to be skeptical about these claims, and plenty of people are. After all, it is a bit of a weird coincidence that two completely separate observatories, 100 years apart, have led two very different sets of scientists to believe in the same hidden giant planet far out in the solar system. But Batygin and Brown are certainly no crackpots out to make gravitational waves. They're incredibly well respected in their fields and have a string of accolades to their names. Konstantin Batygin was named on the Forbes list of 30 scientists under 30 who are changing the world back in 2015. And Popular Science magazine named him one of 2016's most brilliant people. Mike Brown, on the other hand, is, ironically enough, the self-styled man who killed Pluto, having been instrumental in the reclassification of our solar system's pretender to the Planet 9 crown to a dwarf planet back in 2006. He also co-discovered a dwarf planet of his own, Eris, in 2005. With most radical scientific theories that threaten to fundamentally change our understanding of established facts, you have huge numbers of skeptics on one side of the argument, and a few eccentric and passionate believers on the other. A bit like Lowell and his belief in Martians. But when it comes to Planet 9, both sides of the debate are populated with bona fide geniuses, and all of them seem to be talking sense when they argue for or against the existence of Planet 9. So how are we mere mortals supposed to figure out what to believe? Well, as Carl Sagan once said, extraordinary claims require extraordinary evidence. And whilst there is some interesting evidence pointing to the existence of Planet 9, to call it extraordinary would be stretching the truth just a little bit. Even Batygin and Brown themselves concede they can't be sure Planet 9 exists until they actually manage to find the damn thing, which brings us back to our all-important question. If Planet 9 really is out there, why haven't we found it yet? I mentioned earlier that the two most distant exoplanets so far located are 3 million times further away from Earth than Planet 9 is supposed to be. But, as is often the case with very big numbers, it's hard to picture what that really means. So let's shrink it down to human scale. If you, representing the Earth, were standing in Dublin, Ireland, and both Sweeps 4 and Sweeps 11 were in Moscow, Where do you think you would find Planet 9? The answer is also in Dublin. And in fact, rather closer than that. It would be less than 1 meter from the tip of your nose. When you put it in those terms, it's easy to assume that if we haven't found Planet 9 yet, that's because it isn't there. It should be staring us in the face, literally. It's easy to assume that, but neither of us are asses, so we probably shouldn't. In reality, the fact we've been able to locate such distant exoplanets has no real relevance to the hunt for Planet 9. We found Sweeps 4 and Sweeps 11 using a method called transit photometry, which involves monitoring a whole bunch of stars for a long period of time and watching out for any small dips in the intensity of light given off, which might indicate a planet crossing or transiting the star's surface. We use these kinds of techniques because exoplanets are essentially invisible to us here on Earth. They simply aren't bright enough to be seen directly. So we're only able to detect them by watching out for any impact they may be having on their parent star. That makes searching for exoplanets very hit and miss. And when I say hit and miss, what I really mean is a whole lot of missing interspersed with very, very occasional hits. To detect an exoplanet through transit photometry, the Earth, the planet, and its parent star have to be perfectly aligned. Otherwise, a transit won't take place. If you were to pick a random star similar to our own somewhere out there in space, the odds of us being able to detect an Earth-like planet orbiting it at 1 AU using transit photometry would be a little under 0.5%. Think of transit photometry as a brute force approach to finding exoplanets. Monitor thousands of stars over the course of a few years, and you're bound to locate a few exoplanets here and there, despite the relatively long odds. If, on the other hand, you wanted to find a specific planet orbiting a single star, transit photometry would be next to useless. In our own solar system, transit photometry would only be able to help us find the planets with tighter orbits than our own. Mercury and Venus, basically. And both of those are visible with the naked eye. When it comes to searching for Planet 9 and other distant objects out in the Kuiper Belt and beyond, we pretty much have to rely on regular old telescopes, which makes the whole thing a seriously tricky business. Earlier this year, it was confirmed that the most distant object currently known in our solar system is a planetoid called Far Far Out, which is just 140 AU from the Sun. That's only about a quarter of the way to Planet 9. Admittedly, Far Far Out is also far, far smaller than Planet 9 is supposed to be, but still, the point is, we have never detected an object as distant as Planet 9 within our own solar system. Not even close. Which means that just because we haven't found it yet, that doesn't mean it isn't out there. The solar system is very, very big, and the vast majority of it, by volume, is still basically unknown to us. Battigan and Brown believe Planet 9 is so dim it will only just be visible with our current technology given perfect atmospheric conditions, which may only come around a few times per year. So, for now, all we can do is try to predict where we think it should be, then train our best telescopes on that part of the sky, and hope. Earlier, I compared not being able to find Planet 9 in a world where we've already tracked down planets tens of light years from Earth, to finding Yetis in the Himalayas without realizing one's been living in the garden. But in truth, that analogy is a little bit off, because it turns out, if there is a Yeti in our garden, he's chronically shy and fond of dressing up in full-on camo gear. Whereas the few Yetis we found out there in the Himalayas just happens to be in exactly the right place at the right time, and we're yodeling at the top of their lungs. I should point out there are other possible explanations for what might be causing the unusual orbits of the Etnos we've found so far. Perhaps the most interesting of which is the idea that a black hole hidden within our own solar system might be to blame. Before you start worrying the Earth is about to be sucked into a giant cosmic vacuum cleaner, the black hole in question would be a tiny primordial black hole, an as yet purely theoretical variety that may have formed soon after the Big Bang. This particular flavour of black hole is much smaller than your average collapsed star type, being only about the size of a grapefruit, but with a mass 5 to 10 times that of the Earth. As interesting as both this and the Planet 9 theory sound, the truth may actually be far simpler. Remember how the evidence leading Lowell to believe in Planet X turned out to be a red herring? Well, it's quite possible that could be the case here too. Battigan and Brown are basing their assumptions on the very small sample size of ethnos we've been able to study so far. We're talking tens out of a total population in the billions. And drawing big conclusions, planet-sized ones in fact, from small data sets is a dangerous business, no matter how compelling they may seem on the surface. Ultimately, in science, the burden of truth lies with whoever's making the contentious claim. And for now, Battigan and Brown haven't been able to prove their theory. They do, however, believe it's only a matter of time. So I guess that means all we need to do is watch this space. Literally. Thanks for watching. You can get your hands on my book, Stick a Flag in It, over on Amazon or on Audible. Links to both in the description below. Thank you.